many of them, but we're just going to concentrate on a couple of them. And really, honestly, you only need to know a really small amount of information about this. So just keep that in mind while we're going through this. Okay, so physical properties of solutions that are affected by the number of particles, but not the identity of the dissolved solute particles are called colligative properties. So it doesn't matter what salt or what particles are in the solution. It's more of what do they do to the solvent to cause the colligative properties to change. The colligative properties, there are 4 of them. There's vapor pressure lowering, and that's where the vapor pressure decreases as you add solute. Boiling point elevation, again, the temperature, the boiling point difference between the solution's boiling point and the solvent's boiling point. Freezing point's the same idea. It's the difference between the solution's freezing point and the freezing point of a pure solvent. And there's osmotic pressure. And this is just the amount of additional pressure caused by water molecules that move back across a membrane into a solution. So again, this one you really don't need to know anything about. We're going to really kind of focus on boiling point and freezing point. Okay, so substances like sodium chloride, things that can ionize in water, that means that the bonds are strong enough that they can, pull themselves apart from each other, but yet still be salt. And they can kind of mix into that water. So that's being called ionized. And then they also conduct electricity. Those are called electrolytes. Okay. You probably know that term from Gatorade. Gatorade is an electrolyte. Substances like sugar, sucrose, that dissolve in water but don't ionize, right? So sugar molecules, they do dissolve in water, but they don't pull apart like the sodium chloride does, right? And so they don't conduct electricity. They're called non-electrolytes. Okay, so things that have sugar, solutions that have sugar in it, like juices and wines and stuff like that. Okay, if you add salt to pure water, okay, the sodium and chlorine particles spread out in the water, blocking the heat from getting to the water. Okay, so if we have heat coming in from the bottom, let's say there's a burner or something underneath of pure water, the water molecules are going to start moving faster and faster. Okay, if we add sodium chloride, which is salt, right? If we add an ionic compound into that water, those particles are going to break up and they're going to spread throughout the water. Okay. What's going to happen is it's going to lower the vapor pressure, which means that, it takes a lot more heat for those molecules to jump out. So the boiling point of the water is going to increase. So we know that water boils at 100 degrees. Water with salt in it boils a little bit higher. Okay. Because not as many water molecules are able to escape into the air. So that boiling point really needs to get it where they're escaping, right? Becoming steam. Okay. We call that the boiling point elevation. The same is true for the melting point. Okay. Except it's, it's a melting point depression, which means that if I add if I add salt to ice, or water, it's not going to freeze at the same temperature that just water alone will freeze at. It will freeze at a lower temperature. That's why we put salt on ice. Okay. Colligative properties depend on the number of solute particles in a solution. So if we look at sodium chloride, right, the number of particles here are 2 because the sodium and the chlorine can break into ions. If we look at sugar, the number of particles is 1 because sugar can't break down into singular ions or singular particles. Okay, so in terms of this course, what you need to be able to do is tell me which of the following will depress the freezing point more, right? Or the boiling point. So if I'm looking at the answers, I ask myself, how many particles can it break down to, right? And the higher number of the particles, the more it's going to affect that boiling point or freezing point. So sodium chloride, there are 2 particles there, right? There's sodium ions and chlorine ions. C12H22O11, which is sugar, that has just 1 because that's a covalent molecule. Okay, all of these have to stick together. They can't separate, otherwise it's not sugar. Okay, magnesium chloride is magnesium, 1 magnesium and 2 chlorine. So there's 3 particles there, okay, that can spread into the water. And then we have calcium phosphate, where you have 3 calciums and 2 phosphates. So that's 5 particles. So if we're looking at which of the following will depress it more, the 5 particles is bigger than the 3 or the 1. And so the answer would be D, because there are 3 calcium ions and 2 phosphate ions. That adds to 5. The more ions that can separate, the better they are at interfering with making crystals. Okay, so that is colligative properties.